Good morning students. In this video, let's move to next topic in maxima and minima. The topic is called first derivative test. Now, we already know what is maxima, what is minima, what is local maxima and what is local minima. We are going to study first derivative test as the name just related to derivatives. So, again in the previous video, we studied some graphs and I am going to take the same graph here. Okay, let's see the graph. We have a curve y equal to f of x and there is a point z. Now listen, from here to c, the graph becomes decreasing and therefore f dash of x less than 0. From c to here, graph increasing, therefore f dash of x is greater than 0. Okay, do you remember which I said? Here, f dash of x less than 0 because it is decreasing, and then from here, okay, from here means from this point is called turning point or critical point. Okay, so from this critical point or turning point, graph is increasing. So listen, decreasing to increasing, that is called local minima. Okay, local minima. So local minima, repeating, local minima means the sign of f dash of x changes from negative to positive. Okay, sign of f dash of x changes from negative to positive, then it is local minima. Now see, we have another graph. Let's see this graph. Y equal to f of x, and see, this is the critical point C. So from here to C, graph becomes increasing and therefore f dash of x is greater than 0. From C to here, graph is decreasing, naturally f dash of x less than 0. Okay, so increasing to decreasing, increasing to decreasing. I have writing here, the sign of f dash of x changes from positive to negative. In that time we are talking about maxima or local maxima. Okay, so this is the meaning of first derivative test. We are seeing what is the sign of f dash of x. Depends upon the sign of f dash of x, we can define whether it is local minima or local maxima. If the sign of f dash of x changes from negative to positive, then it is local minima. Whether the sign changes from positive to negative, then it is local maxima. Okay. Now let's talk about working rule for first derivative test. That means we know first derivative test, and so we have to find what is the local maxima or local minima value. How would we do that using that first derivative test? It is basically step by step procedure which we have to remember. Okay. Listen, the first step would be what? The first step would be, whatever function given to you, you have to assume that y equal to f of x. Okay, whatever function given to you, have to take or assume that y equal to f of x. Then you have to find out its first derivative, dy by dx. Okay, find the first derivative, dy by dx. Then the next step would be, simply put dy by dx equal to 0. So, okay, dy by dx equal to 0. By putting dy by dx equal to 0, you come to know certain facts that means you will get some linear factors and compare that linear factors to 0. You will get some points. That is our third step, to find critical points. Okay, critical points or stationary points. After getting these critical points, listen, some of these may lead to maxima, local maxima or local minima. So next step is check whether uh, what are these points leading to local maxima or local minima using first derivative or using sign of first derivative. Listen, if the sign changes from positive to negative, okay, positive to negative, then it leads to maxima, okay, leads to maxima, local maxima. Sign of f dash of x changes from negative to positive, then it leads to local minima. So these are the steps to find or steps to verify or check whether the function has local maxima or local minima, or to find the local maximum values and local minimum values. Okay. First you have to take y equal to f of x, then find the derivative and equate the derivative to 0, then find the critical points, and using these critical points we have to find the sign of f dash of x. If it is changes from positive to negative, then f of x leads to local maxima. If sign of f dash of x changes from negative to positive, then it leads to local minima. Okay. Now see these two graphs. So in the first graph, listen, from here to the graph is increasing, isn't it? Now in this graph, from top to bottom, continuously it is decreasing. So there is no changes for f dash of x, positive to negative or negative to positive, something like that. There is no change in the sign. So in this case there is no, we can't say given function has either maxima or minimum. Okay, it's clear? Because the sign of f dash of x now changes its sign. Now changes. So if we take a point C, we can say that this point C is called point of inflection. Point of inflection. So point of inflection means through this point C, there is no change in the sign for f dash of x. It's continuously increasing or continuously decreasing. So at a point C, we can say that f dash of x is continuously increasing or decreasing. Then this point is called point of inflection. That also you have to note it. See the first problem in maxima and minima based on the first derivative test. Okay. Till now we have only first derivative test. So we will do the problem with the help of that only. Let's see what the question has to say. Find all points of local maxima and local minima of the function f given by f of x equal to x cube minus 3x plus 3. Okay. So listen, when a question plainly written find local maxima or local minima, you can either go with by first derivative test or by second derivative test. Now we only start with the first derivative test, so go with that. Okay, let's start. Very easily we know the steps how to find the local maxima and local minima. Let me write. First we have to write the given function y equal to f of x. What is f of x? X cube minus 3x plus 3. I have to differentiate this y with respect to x. That is, we are going to find dy by dx. Derivative of x cube is 3x square. Derivative of 3x is 3. Derivative of 3 is 0. Now here 3 is common, so take it outside. So 3 into x square minus 1, and this can be written as 3 into x minus 1 into x plus 1, because x square minus 1 is the form of a square minus b square. What are the factors of a square minus b square? A plus b into a minus b. Okay. Now First step was y equal to f of x dy by dx. Then equate this dy by dx equal to 0, which implies that 3 into x minus 1 into x plus 1 equal to 0, which implies x equal to 1 from here and x equal to minus 1. So x equal to 1 and x equal to minus 1 are the critical points. This is our third step to find, critical points. Okay, to find critical points. So here critical points are x equal to 1 and x equal to minus 1. Now we want to find whether the function has local maxima or local minima using this critical point. So separately we have to consider these points and verify whether the function has to said to have local minima or local maxima. Let's take the first point, x equal to 1. We are going to find or take any number very close to 1. Listen, very close to 1 and to the right to 1. Okay, very close to 1 and to the right of 1. Similarly, take another number very close to 1 and to the left of 1. Is clear? Right of 1 and left of 1. Right of 1 means just like 1.1, 1.01 and so on. Left of 1 means take any number like 0.9 or 0.99 and so on. So take a number very close to 1 and to the right of 1 and now see what is the value of f dash of x. F dash of x is actually 3 into x minus 1 into x plus 1. If we put 1.1 here, it becomes 3 into 1.1 minus 1 into 1.1 plus 1. Definitely this is positive. This is positive. Therefore, f dash of x is greater than 0. Okay. F dash of x is greater than 0. Now, if we take 0.9 left of 1, then f dash of x becomes, listen, 3 into 0.9 minus 1 into 0.9 plus 1. This is negative, this is positive. Therefore, f dash of x becomes less than 0. So, any value very close to 1 and right of 1, we get f dash of x greater than 0, and a value very close to 1 and left of 1, we noted that f dash of x is less than 0. So from left to right, listen, from left to right, this becomes negative to positive. Okay, so this is the curve, f dash of x less than 0, greater than 0. So f dash of x less than 0 means decreasing to increasing. So this is the point, this is the curve, and therefore this is the point of local what minimum. Okay, local minimum. So we can say that at x equal to 1, listen, at x equal to 1, by your first derivative test, the function is said to have local minima, and the local minimum value is, listen, local minimum value is f of 1. You can see the value of f of 1 equal to 1. Okay. Now see x equal to minus 1. When x equal to minus 1. When x equal to minus 1, listen, take a number very close to minus 1 and left of minus 1. Okay, left of minus 1. Suppose negative 1.1. Now see what is f dash of x. F dash of x equal to 3 into x minus 1 into x plus 1 becomes 3 into negative 1.1 minus 1 into negative 1.1 plus 1. On solving, you can see that this is negative and this is also negative. So negative into negative, positive. So in this case, f dash of x is greater than 0. Now take a number very close to minus 1 and to the right of negative 1.1, I mean negative 1. Suppose negative 0.9. Okay. Now see what is f dash of x. 3 into what? Negative 0.9 minus 1 into negative 0.9 plus 1. So this is obviously negative and this is positive. So negative into positive, negative. That is f dash of x is less than 0. So a number very close to 1 and to the left of negative 1, f dash of x is greater than 0. A number very close to minus 1 and to the right of minus 1, f dash of x is less than 0. So graph is just like this, from left to right. Okay, left is positive and right is negative. So increasing to decreasing. So there is a maximum value and therefore f is said to have local maximum. Local maximum, and the local maximum value is f of minus 1 and f of minus 1 equal to, you can see that, 5. Okay, so in this manner we can find local maximum and local minimum value. I hope it's clear to you. Listen, all these are, I mean local minima, local maxima, all these terms are very important, especially point of inflection. Point of inflection means there is no what, maxima and minima. Okay, maxima or minima. So we will study with the help of problems what all these. Okay, but children, I request you, please watch these videos we have covered in application of derivatives and practice well whatever theory and problem I given to you. Okay.